There are a couple different ways to simplify the difference quotient when our original function is a rational function, a fractional function. No matter how you do it, we're going to end up with the same answer. Just want you to be aware that your method could be slightly different from mine. Your homework, Alex, teaches you to get rid of your denominators by multiplying every term by the LCD, the least common denominator. I like to keep change flipped to get rid of double fractions and then find a common denominator. And that's what I'm going to do in this video, but you're welcome to use another method. Make sure that you show enough steps that I know you did the work yourself instead of Google. All right, so this is our difference quotient reminder, f of x plus h minus f of x over h. So let's jump into it. Example 1, determine the difference quotient for f of x equals 1 over 5x minus 2. I like to start by figuring out what f of x plus h is. So replace every x in the original equation with parentheses x plus h. Simplify. For me, that means to distribute and combine like terms. So I'll distribute my 5. And I don't have any like terms, so that's it. Now for my difference quotient. Take this fraction minus each term of the original equation, but the original equation is just considered one term in itself because it's one fraction. The fraction bar holds it together. All over h. Okay, before I deal with the numerator, the fact that I'm adding two fractions together, or subtracting two fractions together, I hate double fractions. It confuses me. So I am going to first change the division sign, flip. And you may be thinking, hey, there's nothing to flip, it's just an h. But you can write everything over 1. So I kept the numerator as is, put parentheses around it so you hold the whole numerator together. Change your fraction bar is just a division sign, so I changed it to multiplying and then flipped the bottom. I had to write h over 1 so I could flip it to make it 1 over h. And now I'm going to distribute my 1 over h to each of these original fractions. Put the original denominators in parentheses so you hold them together. Okay, that was my first step, was just to get rid of my double fractions by keep, change, flip. Second step is going to be, let's get a common denominator now, so I can write this as one long fraction instead of 2. All right, they both have an h in the denominator. That's good. That's one of my factors. But this first denominator also has a 5x plus 5h minus 2. So I need to put that in the second denominator. Whatever you put in the second denominator, you have to also put in the second numerator. Similarly, the second denominator has a 5x minus 2. Whatever I put in the first denominator, I have to also put in the first numerator. Now it's written as one long fraction, and all that's left to do is to simplify. Remember, simplify means to distribute and combine like terms, and then because we also have a fraction, factor and cancel. I'm going to distribute my minus sign. Combine like terms. I have two x terms on the top. I add them together. They happen to add to 0. I have two constant whole numbers on the top. I add them together. They happen to add to 0. Factor, but the denominator is already factored. I left it separated on purpose, and the numerator is a monomial. It's one term, so I can't factor it. but I can cancel. This h is multiplied by everything else in the denominator. This h is multiplied by everything else in the numerator, so my h's cancel. This is my final answer. So recap of what I just did. I did a keep, change, flip, keep the numerator as is, put parentheses around it, change the division sign, fraction sign to a multiplying, and flip the denominator so I could distribute my h. Then I found a common denominator, so this denominator had to be multiplied down here and up here. The second denominator had to be multiplied down here and up here. I could write it as one fraction now, and all I had left to do was simplify. So distribute, combine like terms, nothing needed to be factored, but I could cancel. Let's do one more example. F of x plus h. So I'll replace every x in the original equation with a parentheses x plus h. Simplify that, which means distribute my 9, and combine like terms, but there are no like terms. All right, difference quotient is that fraction I just found minus the original fraction all over h. I am going to keep, change, flip, then do common denominator, then simplify. So keep, change, flip. Distribute. And now find a common denominator. Last, simplify, which is a long step. So distribute, combine like terms, nothing to factor, but we can cancel our h's.